First, we connect the resistor to the circuit. It reduces the current. This prevents the lamp from burning out. It's important to make sure that the resistor is connected to the positive side of the circuit. Next, we connect the LED lamp. The long leg of the LED is positive side, so it should be connected to the resistor. The short leg, the negative side, is connected to the negative terminal. After that, we add a transistor to the circuit. The transistor ensures the logical operation of the circuit. It inverts the signal. If the input is 1, it outputs 0. If the input is 0, it outputs 1. The collector of the transistor is connected to the resistor, and the emitter is connected to the negative terminal. A resistor is also added to the base of the transistor, and then it's connected to the button. The other end of the button is connected to the positive terminal, completing the circuit. And as you see, the circuit works perfectly. First, we connect our LED lamp. The positive leg of the LED, the longer one, is connected to the positive terminal with the resistor. We should make sure that the resistor is connected to the positive terminal correctly. Then, the negative leg of the LED is connected directly to the negative terminal. Next, we add the first transistor. The emitter is connected to the negative terminal directly with a cable. Then we should add a resistor to our circuit. That resistor must be connected to the positive terminal. The resistor connected with a cable to the base of our transistor. We should make sure that all the cables are connected correctly. Then the connector of this transistor is connected to the resistor that goes to the LED. After that, we connect the other two transistors in series. The collector of one transistor is connected to the emitter of the next transistor. The last emitter, which is left open, is connected to the negative terminal. Each transistor's base is connected to a resistor. This setup forms an AND gate. The LED will only light up when both buttons are pressed. Because the transistors are connected in series, if any input is 0, the output will also be 0 and the LED will not turn on. Then we add buttons to the end of each resistor. The other end of the both buttons are connected to the positive terminal. Finally, the collector of the last transistor is connected to the resistor, and circuit is complete. Let's check if it's work or not. It works. Finally, let's build an OR gate. The OR gate has the same structure as the AND gate. The only difference is that the transistors are connected in parallel, not in series. We separate the transistors that were previously connected end to end, and now we connect each transistor's emitter to the negative terminal. In the OR gate, when either one of the buttons or both of them are pressed, the LED should light up. Finally, we make sure that all connections are properly made. There is a problem on our another button. Now that's okay. Let's check if it's work. Yes, it works. Together with other groups, we build an XOR gate. In the XOR gate, the LED lights up only when one of the buttons is pressed. If both buttons are pressed or neither of them is pressed, the LED does not light up.